My name is Ben Wender. I'm a PhD student in sustainable engineering at Arizona State University. I research life cycle assessment of PV technologies with Tom Seeger and Matt Frazier. I'm going to present to you today a framework for integration of sustainability research at QESST into technical research using Thrust 1 and Testbed 1 as an example. This is a life cycle based framework. Typically, life cycle assessment emphasizes energy and material flows and feedback of a technology life cycle, whereas this framework focuses on knowledge flows, knowledge creation and communication between different groups at QESST. Research at Thrust 1 and Testbed 1 focuses on terawatt scale manufacturing, as well as characterization of cell efficiency and performance over the cell lifetime. This research feeds into the manufacturing and use phase of the PV life cycle. For example, pilot line researchers may develop a new process and recipe for producing a silicon cell, and environmental sustainability researchers would measure the energy and material flows associated with this process and relate them to the efficiency and lifetime production of electricity by this cell. Life cycle assessment requires broad boundaries, so it's not enough to just measure the materials consumed at the pilot plant. You have to understand where they come from and impacts that arise in delivering them there. So we use life cycle modeling software, for example, SEMA Pro or economic input-output analyses, to highlight impacts in the supply chain through mining, benefaction, and electricity production activities, and how these shape the PV life cycle. Similarly, end-of-life impacts have to be considered. So where do panels go after their 30-year use? Are they landfilled? Are they recycled? How efficient are recycling activities? These questions are explored through scenarios, and together all of these tools give a life cycle inventory descriptive of a technology or a new process being developed at Thrust 1. The changes in this inventory are explored through scenario-based modeling. So, for example, scale-up models explore the potential for improving manufacturing and use phase efficiency with increased experience and increased scale. So far, I've only talked about these green boxes, that is environmental sustainability research, but it's important to know that PV research and PV technology in general occurs within a social system, and it has social impacts and trade-offs analogous to environmental impacts. Engagement research done by the social sustainability researchers at QESST feeds into this analysis through changing the boundaries, asking questions like who manufactures, who uses panels, where do these activities occur, and calls attention to equity issues regarding the distribution of benefits and impacts. It also feeds into functional unit selection, so there's a functional difference between a small PV panel used for cell phone charging in Africa and a large $300,000 PV installation on a house in Phoenix. Social values also feed into impact category selection, as different stakeholder groups value different impacts in different categories. Similarly, economic sustainability research feeds into the characterized inventory in terms of a life cycle cost and levelized cost of electricity, and identifying drivers to changes in this cost. So this characterized inventory reflects both social, economic, and social, environmental, and economic impacts. Now, changes in this inventory are explored through sensitivity analysis, so we can identify the most important drivers to changes in this inventory, trade-off analysis to identify trade-offs between social, environmental, and economic impacts, as well as within each one of these categories, and improvement analysis to identify where in the PV life cycle there is the most potential for social, environmental, and economic improvement. The findings are communicated back to researchers at QESST, specifically to Thrust 1 and Testbed 1 researchers, engaging them in a discussion of the sustainability attributes of various research agenda and technology trajectories. Through engaging all of these groups together, we can contribute to the development of more sustainable photovoltaic technologies, and I thank you for your time.